everyone, we're going to find all the local extreme values of the graph of f of x equals negative x cubed plus 12x minus 3. Basically, we're looking for all the local max and min values. And to do that, we're going to look for horizontal tangents. So we're going to take the derivative of our f. So f prime of x is going to equal negative 3x squared plus 12. Now let's factor out negative 3, and that's going to give you x squared minus 4, which equals negative 3 times x minus 2 times x plus 2. So we're going to look at where f prime of x is 0. So I set this to 0, and we have x equals 2 or x equals negative 2. Now let's find our values for that. So f of 2, you go back to this original equation, it's going to equal negative 2 cubed plus 12 times 2 minus 3. That's going to give you 13. And then f of negative 2 is going to give you negative 2 cubed plus 12 times negative 2 minus 3. And that's going to give you negative 19. So basically, we have these points that are going to be your local max and min. 2, 13, and negative 2, negative 19. What we have to decide is which one's local min, which one's local max. One way to do it is to graph the function. So we already know at negative 2, we were at negative 19, so that's down here somewhere. Our y-intercept is negative 3, and at 2, we're at 13. So this is just a little sketch. You have to know your graphs, and that it's a cubic function that's negative. So since it's negative, the end behavior is like that. It means we're starting basically up in quadrant 2 and ending in quadrant 3. So the graph, we could start up here somewhere, and we're just trying to find the, and I'm just sketching this. So I'm going to have to go through these points and then come down here somewhere. All right, and there's your y-intercept. So basically, looking at this, we know this part where the horizontal tangent is your local minimum. This point here is your local max. So we could say that your local max occurs at 13. So local max, you'd say, is 13, and that's at x equals 2. Your local min is negative 19 at x equals negative 2. Put it here. So right there. But this is your local minimum. All right. If you don't want to graph, or you're uncomfortable with graphing, another way to do it is just use your 2 points that we got, our 2 x values, and do a sign diagram. So I can write this as negative 2 and 2. I prefer this method because look at the graph. It's kind of messy looking. So since I call these are going to be your critical values, and we're looking at the x-axis here, so I'll call this x, and we're going to infinity to negative infinity. So if you pick a point, say negative 3, and let's substitute it into our derivative. So we had f prime of x. Let me move this down. I'll do it up here. So f prime of x is negative 3 times x plus 2 times x minus 2. So if I substitute in a negative 3, down here, this is going to give me, we don't care, this is going to be negative, negative, and negative. 3 negatives make a negative. So this interval here is going to be negative. If I substitute in a 0, I'm going to get negative, positive, negative. two negatives make a positive, so this will be positive. And then if I substitute, say, in 3, I'm going to get negative here, positive, and positive. So this is going to go back to negative. And then you can just look at it. Negative means the slope is negative. And these are our critical values here, critical numbers. So that means we're going down somewhere here, then going up. We're going up to 2, then we're going back down like that. So, because this interval here is positive. So that's another good way to do it. Then you could see this is your local minimum, this is your local maximum. And that's it. Thank you. Have a nice day. Bye-bye.